Hello everyone and welcome back. So previously we were developing the data structure linked lists in Python. So basically linked list, a quick recall, is nothing but a single connection between the nodes, and these nodes store data. We use them instead of arrays because they give us more flexibility in popping or inserting new nodes at different positions on the linked list. So in our linked list data structure, we have defined functions for traversing the linked list, for pushing at the end of the linked list, for pushing the node on the front of the linked list, for popping from the linked list, may it be from the tail, may it from the head, or from anywhere in between the linked list. Now we did all of this in the part 1 of the video. So if you haven't watched that out, make sure you watch it. Link is in the description of this video. Right now we are going to code the functions, namely get, set, and insert. So the get function will take in the argument of an index, and what it will do is it will find the node at that index and return that node, and then we can check the value of that node as well. So basically it is going to get the node at a certain index. The set function will take an index as an argument and a value, and what it will do is it will set that value for that node on that index. So you supply the index, it goes to that index on the linked list, and then whatever the value is assigned to that node, it will update it with the new value that you give it as an argument to the set function. So it will set the value at that index, so therefore we call it set function. And now the insert function, what it will do is it will take the index and val as the arguments, and what it will do is it will create a new node of that value and insert that node at that index on the linked list. So now let's begin the coding, and let's start with the get function. So I'll remove the pass and put in the code over here in this block. So as a base condition, if index is less than 0 or greater than equal to the self dot length of the linked list, what we want to do is we want to return an error. Or to be more precise, return index error, because index is out of bound. However, if that is not the case, what we will do is we will put in the actual logic for getting the element. So temp is equal to self dot head. We are assigning head to the temporary variable. We will iterate over a loop in the range of index, and throughout the loop we will do temp is equal to temp.next. So we are iterating over the linked list. When we are outside the loop, we are at the index desired index. So the temp is now pointing to the node on the linked list, which is at the desired index. So we are there. So, and the main objective was to return the node at that index. So we will return the temp, which is pointing to the corresponding index, corresponding node at the desired index. Set function is going to be super easy once we have the get function in our arsenal. What I will do is I will make a call to the get function to get the node at the index and set it, assign it to the variable node. So this node is now pointing to the node at that certain index. So I have the access to that node. And if I have that, the entire problem is solved. I will simply change or update the value of that node to the value that has been inserted to the set function. So here we go. Node.val is equal to val. So now let's proceed with the insert function. What I want to do at the very beginning is check if the index passed as the argument is valid. So if index is less than 0 or greater than self.length, I want to return index error. Else if index is equal to 0, which means we want to insert at the head, What I will do is I will make the call to push head function because basically we are pushing on the head side. Else if self index is equal to self dot length, that is the tail, what we are basically doing is appending at the very end. So I'll make call to self dot push function because that is what it is designed to do. Else what I will do is I will create a new node with a value of val. So now I'm going to use two variables, temp that stands for temporary and prev that stands for previous. So basically previous points to the node that is previous to temp. And I will use a while loop to, or better for loop for I in range of index. I will use this loop to reach out to the node at the index inserted as index value, and such that at when the loop ends, my temp variable will be pointing to the node at the desired index, and previous will be pointing to the node immediately before that. And I want to insert a new node in between, right? So what I will do is, so right now the previous node is pointing to the temporary node. But what I will do is I will make the previous node to point to the new node and new node to point to the temporary node. And that is how the new node got inserted in between. And that is what we want. So let's do that. New node dot next is equal to um, temp, right? And previous dot next is equal to new node. And remember, in doing so, we incremented the length of the linked list. So I'm going to update the length by incrementing it by 1. So now we are done and we have a test case where what we have done is created a linked list which starts from -1 and ends at 5. The traverse function is printing the linked list on the terminal, by the way. So what we will do is we will make use of get and set and insert functions to test them out. What I'm doing is I want to get the element at index 2, then I want to set the element at index 2 with a value of 100, which by the way now is 0 1. So I want to change it with 100, and then what I want to do is I want to make use of again get to get the element and see if the element have been updated, and then I will make use of insert, so to insert a node with value 99 to the index at position 2, and then I want to traverse and see what happened to the linked list in general. So I'll comment it rest of the things out and see how the get function returns us. So we got nothing. It's because just making a call to get function is not enough. We have to print what it is returning us, right? So I'll put the get function call inside a print, and the get function will return us the node and not the value. So what I need to do is I need to print l.get.val. So I think uh, in the previous line when the linked list is being printed, we missed out to move our pointer to the next line, and that is causing uh, very bad readability or visuality on the terminal. So what I'm going to do is when the traverse function is over, I want to make sure that we move on to the next line. So now when I will run the function, one gets printed on the next line, and that shows that when we make a call to get function, it returns us the value at the index 2. Now I'm changing the value at index 2 with 100, and I'll do again a get. So first when the get function is called, it's 1. But next time when the get function is called, it's being called after the set function. So set function sets the value to 100, and when again I make a call to get, it returns me the corresponding new updated value of the node, that is 100. So now let's uncomment the insert function calls as well and test them out. So what it will do is it will insert a new node with value 99 at an index of 2. And does it do that? Yes, it does. 99 is inserted at index 2 before 100 and after 0. And so with this, we have finished developing the linked list data structure with basic standard functionalities fully on our own from the very scratch. The entire exercise of developing the data structure linked lists from the very scratch with basic functionalities is going to benefit us in a lot of ways. It gave us the perspective and the logical thinking perspective of how the data structure works, how the basic functionalities are performed, thereby making us more confident over our command over the data structure. And not only that, the entire things we learned, the entire approaches we saw is going to help us in problem solving as well. So this was a very powerful exercise and I'm glad we did this. Thank you for watching this video.